Now let's graph a logarithmic function. Here we have f of x is equal to log base 2 of x. Remember that that is the inverse function of 2 to the x, which we've written here. Remember the relationship between two inverse functions, where we can simply invert or switch the ordered pairs from the initial one-to-one function to its inverse. And you can see I've written it already here. 0, 1 becomes 1, 0. Similarly, 2, 1, 4, 2, 8, 3, 1/2, -1, and 1/4, -2. And from these ordered pairs now, we can graph log base 2 of x. So let's start at the top here. 1, 0, that's a nice point. 2, 1, 4, 2, I'm writing a 4 there. 6, 7, there's 8 out here, 3. And that gives us the right-hand part of the graph. We got 1/2, -1, and 1/4, -2. And again, we can see how closely this graph approaches the y-axis this time. Now that we've drawn the graph, let's analyze it a little bit closer. Notice that the graph gets closer and closer to the y-axis. We now have a vertical asymptote that this graph approaches but never ever touches. Note the domain will be from 0 to a positive infinity. So this is our graph then, drawn f of x being equal to log base 2 of x. Now from this we want to draw the graph of log base 2 of x minus 1. And remember from our transformations, when we have an inside transformation, we're going to shift this graph to the right 1 unit. So we can take all these points that we've drawn previously, shift those to the right 1 unit. Does not change the shape of the graph, simply slides it over. Important thing to remember here too as well is that our vertical asymptote is also shifted over 1 unit. And so we need to draw that in here as well. So let me get that drawn in there. We'll never ever cross that vertical line drawn in blue here. So we now have our log base 2 of x minus 1 function drawn.